If we have spacecraft that go like this, why can't we have spacecraft that go like this? Hey there, flight suits. Thanks for stopping by D-News. I'm Trace. On December 15th, NASA's Cyclone Global Navigation Satellite System, or CYGNSS, launched into low Earth orbit on a weird launch vehicle. This one. It's horizontal. WTF? Why do we launch everything like this and not like this? When you picture rockets, you probably think the Space Shuttle, Apollo's Saturn V, SpaceX's Falcon, Blue Origin's New Glenn, or Orbital ATK's Antares, or maybe just model rockets at home. Regardless, they're all vertical takeoff launches. But why? In 2013, there were 81 space launches and a handful of failures. In 2014, 92 launches, with 90 reaching orbit successfully. Vertical chemical rockets, they're risky and expensive. They don't always work out. But according to the FAA, flight controllers handle 50,000 flights every day. So why don't we launch sideways? Well, first, we have. In 1963, NASA strapped a tiny plane called an X-15 to the bottom of a B-52. Once they achieved altitude, they sent the pilot just barely into space. These projects were essential in learning how to enter and exit space, how to design pressure suits for pilots, how air friction could heat up the surface of a vehicle, and so many other things. Then in the late 1980s, orbital sciences engineer Dr. Antonio Elias updated his old design and ended up incepting the design of Pegasus, which is the launch you saw at the top of this video. Pegasus launches from the belly of a mothership, a Lockheed L-1011. It's been used since 1990. Put simply, the L-1011 lifts the Pegasus to the regular cruising altitude of about 40,000 feet and then drops it. Then, the Delta-style wings and the rocket engine shoot it toward space, reaching low Earth orbit in about 10 minutes. These horizontal systems have a few advantages. For example, the atmosphere is thinner at 40,000 feet, which means less friction and potentially less fuel use. Airplanes can move the rocket above the weather, avoiding some of those launch challenges. And because you can fly the payload anywhere in the world, you don't need a launch pad. In this case, the Pegasus launched over the Pacific Ocean, about halfway between Hawaii and Australia. Unfortunately, a DARPA study found that when you factor in the cost of the launch vehicles, it can make these launches more expensive. But in the end, airplane-style launches versus vertical launches, they just have different goals. To escape Earth's gravity, a rocket needs to go 7 miles per second, or about 25,000 miles an hour. The fastest airplane ever built, that's the X-15, and it only hits 4,520 miles an hour. Shooting straight up is the quickest way to reach escape velocity and can carry a lot of mass on the way. The Space Launch System that NASA is developing can carry almost 70,000 kilograms. The Pegasus can only carry 443. That being said, the Pegasus isn't the end-all of horizontal flight. The Strato launch system by Vulcan Aerospace could use a 6-engine airplane and fly at 30,000 feet before launching a full-size SpaceX Falcon 9. Assuming we can build it. The plane would need a wingspan longer than a football field, wider than the Statue of Liberty is tall. It's crazy. More realistically, a NASA project is in the works that uses tracks, similar to roller coasters at theme parks, but ridiculously fast. These could be used to propel winged space planes, though at the moment they're only thinking about drones. If you want to launch people, you're stuck with the tech we have now, Spaceship One, which carried the first human on a commercial spaceflight in 2004. It hooks onto the belly of a specialized plane called the White Knight. As commercial spaceflight expands, you'll probably see more of these horizontal launches in the future. So why don't we launch from airplanes? We do, just not that often. Are you wondering why it's so hard to launch rockets sometimes? Well, luckily for you, Amy and I have that answer here. Which is your favorite? The booming excitement of ground-based launches or the screaming free fall of an air launch? Let us know in the comments. Make sure you subscribe so you get more D-News, and thanks for watching.
World's largest aircraft, the Stratolaunch, nears completion. Seattle-based company Vulcan Aerospace announced that its Stratolaunch Systems, an air launch platform for rockets, is close to completion. The Stratolaunch has a wingspan of 385 feet and measures 238 feet in length. The 6-engine aircraft is currently the world's largest. The Stratolaunch is designed to carry rockets weighing up to 275 tons. It would take off from a runway with the rocket attached to its belly and release the rocket when it reaches 35,000 feet. The rocket then fires its own engine and travels towards its orbit. Stratolaunch is designed to make air rocket launches into low Earth orbit a routine commute. The Stratolaunch systems are expected to be completed by the end of this year and is estimated to start commercial services before 2020.